Okay, hello guys, how are you? So we're going to start with chapter 7 today. So chapter 7 has 3 subtopics. So the first subtopic is acids and bases. So the second subtopic is about titration. And the third subtopic is about solubility. So for the first subtopic, I'm going to divide it into two. So this is the first part, and then we will have the second part. Hopefully it will be shorter lah. But the first part ni, it's not that complicated. It's somewhat similar to what you learn in chapter 6 before this, okay? Alright, so before that, we're going to dissect sikit what does ionic equilibrium mean. So kalau before this, we learn about chemical equilibria. So maksudnya dia boleh jadi your compounds without charges, okay? Bukan ions. So kalau ionic equilibria, maksudnya it is your ions in equilibrium with each other. So how does your ion how can you have ions in your equilibrium mixture? It means that it must have dissociated in water, okay? It must be in solution, right? Okay, so we're going to look at our learning objectives. So today we're going to define what is acid and what is base. According to these two theories, we have Arrhenius theory and Bronsted-Lowry theory. Okay, and then we're going to identify which are conjugate acid, which are your conjugate bases, okay, using this theory. Simple je. And then you're going to relate pH and POH to the ionic product of water, right, at 25 degrees Celsius. Also, we will define what is a strong acid and base, what is weak acid and base, okay, what are the differences, okay, we will see macam mana nak bezakan diorang tu, how to identify. Then we're going to get to know what is pH. I think you have an idea what is the pH scale, POH, and then pKw. Now we're going to learn how to calculate the pH values of a strong acid and base. Okay, relate the strength of a weak acid and a weak base to the acid and base dissociation constant. So you will meet new constants, okay? Ka, Kb. Masa ada Kw yang tadi tu. Okay, so macam there's a few new terms lah. Then perform calculations, okay? Ini ada, those table, ice table, ada IF table, ada dua je table. Tapi macam calculation dia, in my opinion, it's quite straightforward, okay? Alright, so we have two theories, okay, to define acid and base. So the first one is Arrhenius theory. So Arrhenius theory, it defines acid as any substance that dissociates in water, okay, to produce hydrogen ions or hydronium ions. So you will get, when you put the acid in water, it will dissociate, maksudnya dia akan terlerai, and you will get your H plus and H3O plus. Itu menunjukkan the acidity, keasidan dia, menunjukkan sifat asid dia tu. So here you have HCl equals, so right here your HCl, it is already in aqueous phase, so it just dissociates completely into H plus equals and Cl minus equals, right? And then you have HCl here as well in water. So when you put your water as your as your reactant as well, then you will get H3O plus, okay? That means that this H plus, the H will be donated to this water, your base in this case, and it will become H3O plus, okay? And then this is your Cl minus, okay? Next, we have the base. So the base is any substance that dissociates in water to produce hydroxide ions, alright? So hydroxide ions maksudnya akan menunjukkan the basicity of your substance. Okay, so here you have sodium hydroxide ion, sodium hydroxide compound. that will dissociate into sodium plus ion and hydroxide ion in aqueous phase. Okay, alright. Oh, one more thing about this chapter, when you write the chemical equations, make sure you put the phases. Alright, so make sure your water must be liquid because it is a pure substance. Yang lain usually it will be aqueous. Okay, because your ions, it must be in aqueous phase. So because that is the only way for it to terlerai. Kalau solid, tak boleh lah dia terlerai. Okay, dia dalam compound yang mempat. Okay, next we're going to define acid and base using Bronsted-Lowry theory. Okay, so yang tadi tu we talk about the apa ni tadi tu kita cakap pasal producing dissociating it and producing. Okay, producing H plus and H3O plus dengan OH minus kan, right? Apa tu? Apa nama perkataan tu? Okay, yang tu proton transfer. Ni proton transfer. Okay, so lepas tu for Bronsted-Lowry pun we will talk about proton transfer. Okay, oh tak, yang tadi tu cakap pasal dissociation, tapi yang Bronsted-Lowry ni we talk about proton transfer. Okay, H plus transfer. Maksudnya there will be an acceptor and there will be someone who donates the donor. So your acid will be the substance that will donate the proton H plus to other substances. So there's right here we have two reactions, ionic equilibrium. So the first one, you can see that HNO3 here. Okay, if you want to see if it donated the proton atau water donated the proton, so we'll do it this way. Okay, aku kena identify mana dia punya conjugate. Alright, so from there you can see that HNO3 is your HNO3 tu siapa? HNO3 is your okay, first HNO3 has a proton right here, and then it donated one hydrogen, so it doesn't have any a proton anymore. So the proton is accepted by this water molecule. So this water molecule, it accepts the proton and forms the H3O plus ion. So that means your HNO3 will be the acid, right? Because it donated a proton to another substance. So NO3 tu apa pula? So NO3 tu, we learn this term, nama dia conjugate. It will be your conjugate base. So nanti kita tengok lagi lah lepas ni, tapi I just tell you now. So your water ni, it can act as acid or base. So in this reaction, it acts as base. Okay, it acts as base because it is in reaction with an acid. So here you have your conjugate acid. Alright. Okay, also notice that the signs of these two reactions, they are different. So here you have a non-reversible reaction, and here you have a reversible reaction. Nak cakapnya TLDR, this means that your first reaction is goes into completion. Okay, maksudnya your acid dissociates completely. Okay, it doesn't go back to form your acid and base again. It dissociates completely. Habis dah. Yang NH4 plus ni, it is a reversible reaction because this is your weak acid, and your weak acid will dissociate partially, ionize partially. Okay, does not go into complete dissociation. Maksudnya it will be in equilibrium. Okay, so NH4 plus, mana dia punya pasangan? NH3 H2O pasangan dia H3O+. That means NH4+, you can see that it has 4 hydrogens here, and then here it has 3 hydrogens. That means that your ammonium ion, okay, in aqueous phase has donated 1 proton, okay, to another substance to form its conjugate base, ammonia. So this will be your acid, and this will be your conjugate base. Okay, your water right here, again, it acts as the base. Okay, so base will accept your proton and it will form your conjugate acid. Okay, right. So ni macam basically I have terangkan in those last two equations pasal base sikit. So base is any substance that can accept a proton H+ from other substances. So NH3 aqueous, right? So dia react with water to form ammonium ion and hydroxide ion. So let's see, your NH3 akan form NH4+, your water will form hydroxide ion. That means that your NH3 aqueous, okay, it will form NH4+ aqueous ion. That means this is your base because it has accepted a proton. Okay, so that's your conjugate acid. Your water, tengok so sekarang from water it becomes hydroxide ion. Maksudnya dia lose 1 proton, right? Donate 1 proton to another substance, which is NH3. That means that here your water is acting as an acid. Alright. Okay, we will see why your water can act as acid or base later. Okay. Alright, so yang ni pun sama juga. Ni CO3 2- forms HCO3, and then your water forms hydroxide ion. Okay, boleh tahu kan siapa base, siapa acid, and then which is the conjugate acid and which is the conjugate base. So basically Bronsted-Lowry is talking about the proton transfer. So acid is the one that donates proton, okay? Base is the one who accepts proton, alright? Okay. Sekejap. Okay, sekejap. Takut kalau dia tak record. So, from Bronsted-Lowry theory, we can talk about the conjugate acid-base conjugate pair. Okay, the relationship. How do they relate to each other? So conjugate base is basically a species that remains, species yang tinggal when 1 proton has been removed from the Bronsted acid. Okay, so maksudnya macam tadi tu lah, after you remove 1 proton from your Bronsted acid, okay, acid donate proton, and then what is on your right, your product is the conjugate base. So conjugate acid pula, a species that remains when 1 proton has been added to your Bronsted base. So your Bronsted base will accept 1 proton, so that product is your conjugate acid. Okay, alright. So one more thing pasal conjugate acid dengan conjugate base ni, the relationship is that if you have a strong acid, dia akan cakap kat bawah ni, so saya tak cakap lagi. Okay, so right here, okay, kita tengok this equation first. Okay, so HCO3, to know which is your acid base conjugate acid conjugate base, we're going to do that. Okay, so you're going to see that HCO3 forms CO3 2-, right? So daripada ada hydrogen, tiba-tiba tak ada hydrogen, maksudnya dia dah donate 1 proton. That means that this is your acid. Your water will act as a apa? Okay, your acid ni, astaga guys. Okay, so your acid, so this is your conjugate base. Okay, and then this water will act as your base because it accepts 1 proton. So this will be your base. And this will be your conjugate acid. Okay. So, one more thing, you can see that this is a reversible reaction. So that means that your reactants and products, your acid base, conjugate base and conjugate acid, they are in equilibrium. That means that this acid is a weak acid. Okay, it undergoes partial dissociation atau partial ionization. Maksudnya dia tak ionize completely, dia tak lerai secara completely, tapi dia akan ada tinggal lagi asid ni. Faham tak? Maksudnya produk awak punya reactant still ada kat dalam your reaction chamber. Right. So the relationship between your acid and conjugate pair is that a weaker acid has a stronger conjugate base. Okay. I'm going to tell you that HCO3- is a weak acid. So this weak acid HCO3-, when it donates a proton, it will form this conjugate base. Okay, nak cakapnya, because this is a weak acid, dia akan dia punya acidity, maksudnya dia punya ability to donate proton, okay, proton, donate proton is not that strong. That means that dia susah nak donate proton. Okay, dia sayang dia punya proton. That's not very acid of it. Okay, sifat acid is that dia suka donate proton. Okay, so this is a weak acid. So when it forms the conjugate base, this conjugate base punya sifat will be a strong conjugate base. So it is a strong conjugate base because it will dia akan readily accept pula, dia suka pula accept proton. Faham tak? So dia akan relate lah to each other. Kalau awak ada strong acid, dia akan weak conjugate base. Kalau weak acid, strong conjugate base. Okay, strong base, weak conjugate acid, macam tu. Okay, tapi in this case, this is a weak base, strong conjugate acid. So H3O+ is a very strong acid. Okay, alright. Okay, that's the relationship. So now we're going to see the strength of your acids and bases. Okay, what is going to determine the strength of your acid and base, right? So it will depend on the extent of your dissociation. Remember dissociation, that word? Remember, kalau daripada chapter 6, you know X, right? Your delta change in concentration, delta change whatever lah. Okay, so kita jumpa balik percentage of dissociation atau percentage alpha. Okay, the formula is still the same. You are still going to use delta concentration, change in concentration, over the concentration initially times 100% for percentage, and your degree of dissociation will be this. Alright, so that's the formula that we'll still use to measure the strength of your acid and base, whether it is weak or it is strong. So we're going to look at first our strong acids. Okay, cuba teka awak punya strong acid tu, dia akan dissociate macam mana. Okay, your strong acid, it is an acid that will ionize completely in water. Maksudnya, it will become ion. Okay, it will become ion and not go back to its reactant. Okay, in water. So who are they? They are hydrohalic acids. You have HCl, HBr and HI. Oxo acids in which the number of oxygen atoms, oxo maksudnya awak punya acid tu ada oxygen, so the number of O atoms exceeds by 2 or more the number of ionizable protons. So in this case, you have HNO3 kan. So tengok awak punya ratio of hydrogen to oxygen. So awak ada 1 hydrogen. Okay, bila awak tengok oxygen awak ada 3. Maksudnya dia exceed by 2 or more. So at least you have you must have 1:3 ratio, okay, of your hydrogen to oxygen. So ini exceed by 2 or exceed by 2 kan. So maksudnya this is a strong acid. Ini petanda yang dia adalah strong acid. HCl4 pun sama. Ni awak ada satu je and then you have 4 oxygen. So memang acid lah. So it's important for you to know, okay, to identify whether your acid is strong or weak, okay? Because nanti when you do calculations, you will need to draw tables. So from the strength of your acid, you will know which table to draw in order to calculate, okay? Okay, so these are the 3 ways for you to write for your acid dissociation. Okay, so notice that for your strong species, you will have this single-headed arrow. Okay, that means that it is non-reversible and your reaction goes into completion. Okay, it means that your reactant here, it ionizes completely into ions. Okay, becomes ions and then it doesn't go back. Okay, so this is the first way for you to write your equation. Your HCl equals compound will dissociate into H plus equals ion and chloride ion ini equals phase. Second, your HCl equals, okay, in the presence of H2O liquid, outwards macam ni, then you'll get H plus and Cl minus juga. Okay, yang third one ni, when you react with water, okay, when you react with water, your water is your reactant, then you will get H3O plus, okay, because kenapa? So maksudnya your acid ni dia akan donate proton kan, so dia donate proton kepada siapa? This water. So this water will be your Bronsted base. It will accept proton and form H3O plus, right? Okay, so when you have H plus ni, that means that your acid is showing its acidity lah, keasidan dia. Dia nak tunjuk yang dia ada dia tu acid lah. Okay, macam tu. Right, so example, for the dissociation of 0.1 molar of HCl. So you know HCl is a strong acid, okay? That means it will undergo it will ionize completely, okay? It will have a non-reversible reaction, okay? So right here I have my chemical equation with phases, okay, with water and then with a single-headed arrow. Okay, saya akan tulis macam mana nak buat yang ni. Okay, macam mana? Alright, so for strong acid, okay, from here we know that it is a strong acid. Then I want to show you that it will dissociate. Okay, it will undergo, its percentage alpha will be 100%. Okay, and its alpha will be 1. Okay, for strong acid. So I'm going to show you now. So first we're going to, let's draw the ice table. So ini initial. Okay, then you do delta concentration, change in concentration, and then you do concentration final. Okay, so you know that it has an initial concentration of 0.10 molar for HCl. So your water, you're not going to write anything, okay, because water has a constant, it is a weak electrolyte, so you don't need to masukkan, okay. Also it's a pure substance. Cl minus, your product, and H2O plus is not formed yet initially. Okay, since it is a strong acid, then your delta concentration will be minus 0.10. So because your strong acid will dissociate, ionize completely, okay, dia tak akan tinggal kat dalam awak punya reaction chamber. It will not be in your product, Okay, it will be consumed completely. So now your Cl minus pula, it will be plus lah, 0.10. H3O plus pun plus 0.10. So that means your final concentration for your products will be this way. Astaga. Okay. Okay, so if you do the percentage of dissociation, percentage alpha, you will use the formula HCl kan. HCl punya dissociation, okay, delta over the initial, right? Initial concentration. Okay, if you masukkan je, times 100% je, it will be 0.10 over 0.10. Negatif tu tak payah ambil, kita nak ambil X je kan. Okay, times 100% and then you will get berapa? You will get 100%. Okay, kan saya dah bagi tahu. And then if you do the alpha kan, buatlah, then you get 1.00. So that shows that your strong acid, it ionizes completely in water. Okay, so maksudnya, itulah maksudnya. Okay. Alright, so next, strong base pula. Kalau strong base, it is a base that ionizes completely in water. So who are they? You have to know who are they. Okay, your strong base, they will be in the form of M2O. M tu apa? M is your metal, or MOH. M is your metal from group 1. So this one, it will be a metal oxide. This one will be a metal hydroxide. Okay, OH2 hydroxide. Right, OH minus kan hydroxide ion. So boleh jadilah sodium hydroxide ke, potassium hydroxide ke, boleh jadi lithium oxide ke. Okay. Another one is, it can be ROH2, itu pun oxide dengan hydroxide, but your R is calcium, selenium ke, dengan barium. Okay. Right, so make sure to note atau macam buat list lah, strong acid, strong acid dengan strong base. Okay, because strong acid dengan strong base, lepas tu nanti weak acid dengan weak base, so that awak familiar dengan diorang. Okay, so ini dissociation of 0.50 molar of sodium hydroxide. Basically sama je macam tadi, it will undergo 100% dissociation. Okay, awak boleh buat sendiri kot. So that's your chemical equation. Note that it has a single-headed arrow. That means that your reaction goes into completion. It is non-reversible. Right? Okay, so now weak acid. Okay, we already looked at strong species. Now we're going to look at weak species. Okay, your first one is weak acid. So weak acid, it is an acid that ionizes partially in water. Partially maksudnya apa? Separa kan? Maksudnya not completely lah. So who are they? Who are these weak acids? They are hydrofluoric acid, HF, acids in which H is not bonded to oxygen or to halogen. Okay, bukan macam HCl, bukan macam HBr, so dia HCN, bukan halogen, H2S. HF ni dia halogen kan, F tu halogen kan, tapi dia weak acid. Okay, right. So oxo acids in which the number of oxygen atoms equals or exceeds by 1 the number of ionizable protons. So here you have your oxygen 2 and 1 hydrogen. So your oxygen exceeds by 1 only. Okay, ini the number of oxygen is equal to the number of hydrogen in your acid. Okay, maksudnya itu weak acid. Another one is you have your organic acids. In this general formula, RCOOH. So COOH ni adalah carboxyl group awak. Okay, so they are your carboxylic acids. So this is your ethanoic acid, and this is your formic acid. Okay, COOH ni menunjukkan yang dia adalah weak acid. Okay, maksudnya dia tak ionize completely, dia partially. Okay, for example, okay, for a dissociation, for weak acid, any weak acid, let's say denoted as HA, the dissociation reaction is like this. So you have your weak acid HA dissociate dissolve in water and dissociates as A minus equals and H3O plus equals. Alright, so you can see that this is reversible arrow, this equilibrium arrow, it shows that you have a weak acid. Okay, so the percentage dissociation will be less than 100%. Okay, it does not completely ionize, dissociate. Your degree of dissociation will be less than 1. Alright, okay, tu yang saya cakap tadi. Right, since your your for weak acid, your chemical equilibrium will be like this, your ionic equilibrium will be like this, your ionic equation will be like this. It is reversible. That means that your weak acid, water molecule, A minus ion dengan H3O plus ion, it will be in equilibrium with each other. Betul? In equilibrium maksudnya dia akan exist in that chamber. That means that your acid does not dissociate completely, ionize completely, but it will, ada je lagi yang tinggal kat dalam chamber awak. Ada je yang tak ionize lagi. Faham tak? So sebab tu dia in equilibrium. So kalau dulu kita belajar dalam chapter 6, dululah sangat kan, last week, kita belajar chemical equilibrium constant K kan. So yang tu because awak punya reaction is reversible kan. So sekarang ni we have acid dissociation constant expression Ka for your acid. So itu pun because your ions are in equilibrium with each other. Alright, so the expression will be written this way. Okay, you have your A minus ion dengan H3O plus ion. Okay, the concentrations over concentration of your weak acid HA. Okay, you're not going to put in water because water is a pure substance. Okay, right, macam biasalah. Okay, ingatkan macam nak buat ni. So your Ka value, it depends on temperature. It will depend on temperature whether also whether your reaction is endothermic atau exothermic. Okay, kita dah belajar kan? So normally Ka is measured at 25 degrees Celsius and the value of Ka, okay, if your value of Ka is low, maksudnya apa tu? What does it tell you? If your value of Ka is low, that means that the concentration of your H3O plus and A minus is low. Okay. If your concentration is low, that means that did your acid ionize completely? No, maksudnya awak dapat sikit je H3O plus. So that means your ionization, degree of dissociation is also small. Okay, tak dissociate banyak pun. Okay, kalau strong acid tadi satu kan, tu maksudnya dia fully dissociate. Ini maksudnya less than 1, sikit lah. That means that the strength of your acid is weak. Okay, is low, is weak. So you have weak acid. Alright, so that's the relationship between Ka, degree of dissociation, and the strength of your acid. Right? Okay, kalau weak base pula is your base that ionizes partially in water. Who are they? They are your ammonia and amines. Alright? So, note ini ammonia tau. Kalau NH3, Kalau ammonia awak punya base, dia accept satu proton, dia akan jadi apa? Dia akan jadi NH4+. So NH4+ is ammonium ion. Okay, ammonium ion. It's not the same as ammonia. That means that this is not your base. Okay, this will be your acid. Kalau daripada NH3 to NH4+, maksudnya it will be your conjugate acid. Okay, so this is not your base. Okay, so just nak note that. Okay, another thing is your amines. So amines tu apa? Amines nanti awak belajar next sem dalam organic chemistry. So nak senang, awak tengok dia ada nitrogen ni. Okay, nitrogen, lepas tu dia ada R group. Okay, ada 1 R group, 2 R group, 3 R group. R group tu apa? Yang ni lah awak punya berapa banyak carbon yang bonded to your nitrogen. Okay, oh ni cider, ni tak ada hydrogen kat sini Okay, so nak senang, awak just ingat yang dia punya nama macam ada amine kat belakang. Okay, ada amine kat belakang pasal ada nitrogen. So ingat yang these are your weak bases. Alright, so macam weak acid, weak base ni lain dia. Dia bukan produce H3O+ atau H+, tapi dia produce OH-. Okay, but it still dissociates in water. Your weak base, it still dissociates in water. Right? And then to form your ions. Okay, tengok ni ada OH- ion, hydroxide ion. Okay, that shows your basicity, betapa basicnya dia. And then you have a reversible arrow, equilibrium arrow. So maksudnya it is a weak species. Okay, it doesn't go complete dissociation. Okay, percentage alpha less than 100, percentage degree dissociation less than 100. Okay, so base dissociation constant expression Kb. Okay, tadi kita ada Ka, so now we have Kb. So what does Kb tell you? Kb tells you the strength of your base. Okay, so Kb will tell you if you have a small value of Kb, that means that your concentration of hydroxide ion, okay, of your ions up there is very small. Okay, that means that you did not make a lot of hydroxide ion. So that means awak punya ionic equilibrium tu, awak punya base tu is a weak base lah. Okay, so dia tak ionize completely. So degree dissociation awak small. Okay, tak banyak pun dia dissociate, dia still ada reactant tu. That means dia tak tunjuk lah how basic it is. Okay, dia punya strength is weak base, very weak lah. Okay, so for the first example here, okay, I'm going to show you. Okay, kita buat yang ni sebab yang ni macam penting lah juga, tapi senang kot awak nak tangkap. Okay, at 25 degrees 25 degrees Celsius, 4.2% of 0.10 molar of formic acid HCOOH dissociated in aqueous solution. Calculate the acid dissociation constant Ka for formic acid. Okay, so apa yang patut kita note, apa yang patut kita keluarkan, apa yang patut kita note is that here you have the percentage of dissociation, okay, percentage alpha for your formic acid, and this will be your initial concentration of your formic acid. Okay, ini formic acid awak. So, formic acid awak, if you look at the general formula, chemical formula, you have COH kat belakang. It is a carboxylic acid. Okay. So, you know that it is a weak species, weak acid. Okay. So, disuruh cari Ka. So, how do you find Ka? What is the formula for Ka? First, you need to know how does your formic acid dissociate. So, let's just write down the chemical equation, ionic equation for it. Okay, so you have here COOH, okay, equals, and then it dissociates in water, okay, in the aqueous solution to form berapa? To form apa? So it is an acid kan, so it will, okay, it will lose one proton and form HCOO minus equals plus, so your water will accept one proton and become H3O plus equals. Okay. Alright. So, tengok balance ke tak? Okay, kalau dah balance, bolehlah tulis awak punya Ka. Awak punya expression. So, what is the expression? You have HCOO minus. And then you have H3O plus. Over HCOOH. Okay. Water tak masukkan Okay. So, what do we need? Okay, for Ka, you need to find the concentration of this species at equilibrium. So that means what do you have to do? So for weak acid, you need to draw the ICE table, your ICE table. So you're going to write down concentration at initial, delta concentration, okay, change in concentration, and then you have the concentration at equilibrium. Okay. So for initial concentration, dia dah bagi tahu it is 0.10 molar for your formic acid. Water tak payah tulis. Okay. Lepas tu your ions HCO minus 0, H2O plus 0, because the products have not been formed yet initially. So the change in concentration will be berapa? Okay. Berapa? X ke? Adakah dia X? Awak tak tahu ke? Awak tahu kan? So, awak tahu yang percentage alpha is 4.2%. So, what is the formula to find formula for your percentage alpha? It is your apa tu? It is your delta concentration. Okay. Delta concentration over initial, right? Initial concentration. So, initial concentration over 0.10. Saya masukkan terus. Times 100%. So, can you find your delta concentration? Your dissociation. Boleh kan? So, berapa tu? It will be 0.0042 molar. Okay, dah dapat tu. Boleh masuk kan? Boleh kan? So, ini make sure ada minus 0.0042 molar. Okay, yang lain plus lah. Kan, sebab kita dah tahu kan? Okay. So, the concentration at equilibrium will be 0.0958. This one will be 0.0042. This one will be 0.0042 as well. Okay. Okay, dah dapat that information. Can you find Ka now? Boleh ke tak? Boleh kan? Wow, kenapa saya cakap macam tu? Macam baik sangat. Okay, so you can find Ka. So, plug in your values. The concentration of HCO minus 0.0042. 0.0042 over 0.0958. Okay. So, now dapat berapa? 1.8 times 10 to the power of minus 4 molar. Okay, dah dapat Ka. Right. Dia minta Ka kan? Okay. Dah siap kan? Right. Okay. So, I want to tell you another thing. One more thing. Important thing. Okay. So, if your Ka or Kb, okay, for many weak acids, okay, untuk acids and bases yang partially ionized ni, their Ka or Kb will be less than 10 to the power of minus 5. Okay, maksudnya dia punya Ka dengan Kb tu very small. So that means that the degree of dissociation is very small as well. Very small. Maksudnya X dia tu, kan, dia punya X tu kecil sangat. Okay. So, when that happens kan, okay, you can use the assumption. You can assume that concentration of your initial, okay, kan, bila awak buat tolak dengan delta of concentration, it will be equal to your initial concentration. What does that mean? That means that this value here is very very small lah. Okay, it is very very small sampai dia jadi insignificant lah. So awak boleh assume that your initial concentration is that your bukan awak punya ni lah untuk cari apa ni, equilibrium ni kan, equilibrium awak ni, initial concentration tolak ni sama dengan initial, sama je dengan awak punya equilibrium. Okay, faham tak? Maksudnya awak punya X tu very 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 small. Okay, because your Ka is atau Kb is very 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 small. So you can assume that the concentration at initial is equal to the concentration at equilibrium for weak acid and bases. Alright. So let's say when you use this assumption, it will give you the answer correct to at least 2 significant figures. Okay. So if your value of Ka or Kb is less than 10 to the power of minus 5, or the percentage of alpha dissociation is less than 5%. Ingat tak kita pernah buatkan assumption ni, tapi kita recall lah. So bila awak kira apa benda, okay, kalau macam ni kan, tadi awak minus this one kan, awak untuk apa ni, sorry apa saya cakap ni, okay, untuk equilibrium awak ni kan awak dah minus with X kan. Okay, so value awak punya equilibrium yang ni kan, tengok kalau saya buat without kira X tu kan, saya assume je terus 0.10 molar the initial concentration, jawapan dia akan sama juga, 1.8 times 10 minus 4 molar. Okay, two significant figures lah. So itu bila awak punya Ka is very small so when it is less than 10 to the power of minus 5. Right. Okay, itu je untuk saya nak tunjuk awak. Okay. Alright, macam tu So yang ni, dua ni awak boleh buat sendiri. Okay, now we're going to talk about water pula. Right, kenapa dengan water? Oh my god guys, I just realised something. Saya tak pakai earphones. Okay, dengar tak? Okay, now we're going to talk about water pula. Did we cut that? Okay. So, now we're going to talk about water and the pH scale. So, apa yang special pasal water? Okay, why does water have this constant? Is your water constant? Okay, so the water ionization constant Kw is when your water molecules are ionized. Maksudnya dia jadi, our molecule jadi ions. Okay, dia akan transfer proton from one water molecule to another. Right? So this water molecules, so let's say this one will transfer one proton to this water molecule and then it will form OH minus. Yang ni. Jadi OH minus. And then this one will be H3O plus. Maksudnya dia adalah the water molecule that accepts the proton. Alright, and then you get H3O plus ion and OH minus ion when your water dissociates. Alright, so because of that, we can have a equilibrium constant expression for your water. Because your water ni, dia reversible lah reaction dia. Dia boleh jadi these ions, dia boleh jadi water molecule balik. So, your Kw, it is equal to 1.0 times 10 to the power of minus 14 at 25 degrees Celsius. Okay, macam mana boleh dapat minus 14 ni? It is because the concentration of H3O plus is 1 times 10 to the power of minus 7. Okay, and the concentration of your hydroxide ion in water pun sama. 1 times 10 to the power of minus 7. Okay, so bila awak campur dapatlah, bila awak kali dapatlah 10 to the power of minus 14 tu. Okay, so itu adalah awak punya Kw. Okay, constant for water ionization constant. When your the constant, kira equilibrium expression jugalah untuk awak punya water. Okay, so yang ni nanti awak boleh guna untuk cari concentration of your H plus, H3O plus, H3O plus dengan hydroxide ion, right, dalam apa-apa lain solution. Okay, so the temperature of your water will 17 berapa the temperature of your water will increase. The temperature of your water will increase. When the temperature of your water increase, okay, your Kw will increase as well. Okay, why is that? Because the dissociation of water is an endothermic process. Ingat tak endothermic tu apa? Endothermic maksudnya awak punya delta H, enthalpy change is positive. That means your forward reaction is endo and your reverse reaction is exo. Okay, so kalau awak tinggikan, awak recall Le Chatelier's principle, when you increase the temperature of your system, then your system will try to reduce that disturbance. Maksudnya dia akan try to lower the temperature. So how do they lower the temperature? They will favor the endothermic reaction because the endothermic reaction will absorb heat. So maksudnya by going forward, okay, this endothermic reaction here like this, you will reduce the disturbance. Okay, so that means bila awak tinggikan temperature, you will make more ions. Alright, you will dissociate your water. So when you dissociate your water, banyaklah awak punya concentration of H2O plus dengan OH minus. So because of that, kalau dua ni naik, kan, then Kw awak pun naik lah. Alright, so itu bila awak tinggikan temperature lah. Okay, so nanti awak punya Kw tu bukan 1.0 times 10 minus 14 lah kalau awak tinggikan temperature, because this is the value at 25 degrees Celsius. Okay, So now we're going to talk about pH scale. Okay. pH scale, pernah dengar kan? What is pH scale? It is the scale that is used to express acidity. So maksudnya nak bagi tahu awak how acidic is your substance, is your solution. Okay. It is expressed as the negative log of H3O plus or the negative log of H plus. Okay. So dua ni. Ni yang menunjukkan keasidan dia. So, maksudnya, awak tahu kan kalau pH awak low, maksudnya dia acidic kan? Why? Because bila awak punya concentration of H3O plus dengan H plus tinggi, okay, pH awak low because you have this negative log. So, maksudnya value dia akan jadi small lah bila awak punya concentration tu tinggi. Faham kan? Okay. You also have POH. So, POH pula untuk express the basicity. Okay. So, sama juga kalau awak punya hydroxide ion concentration tinggi, then your value of POH will be smaller. Alright? Boleh kan? Okay. So, this is just basically to say that when your pH is less than 7, that means your solution is acidic. So, if it is more than 7, it is basic. So, if it is equal to 7, it means that when pH is equal to 7, it is neutral. Okay? Alright. Okay. One more thing I want to tell you is that, one more thing you need to remember is that when pH, okay, kalau dalam water awak ada ni kan, awak punya value is dalam water awak punya concentration of acid H plus dengan H2O plus dengan OH minus sama. Jadi bila awak campur the pH, okay, for water and the POH for your water, you will get 7 plus 7. So, you will get 14, okay? So, nak bagi tahu tu je lah. So, bila awak cari, So, bila awak boleh guna this formula to find pH atau POH, okay? Either way, yang mana-mana yang awak diberi, alright? Okay, so now we're going to conclude the relationship between your strong, your H plus, your OH minus, Ka, Kb, pKa, pKb, pH or POH, okay? So, for strong acid, maksudnya dia undergo complete ionization. Then you will have a high concentration of H plus. That means that your Ka, your acid dissociation constant will be high as well. Okay. pKa macam mana? So your pKa akan tinggi ke atau akan rendah? Kalau pH negative log kan? Maksudnya kalau pKa tu negative log jugalah. Negative log Ka. Okay. So kalau dia negative log kan? Negative log Ka, maksudnya kalau awak Ka tinggi dan awak punya pKa rendah lah. Right? So your pH pula is negative log of concentration of H plus. So just now for strong acid, you will have high concentration of H plus. Therefore your pH will be small, okay, low. Kan, betul kan? Right. For weak acid pula macam mana? It will be the opposite. You will have low concentration of H plus and you will have low acid dissociation constant, and then you will have high pKa and high pH. Higher lah relative to strong acid. Right. Strong base macam mana? Kalau strong base, strong base kan, maksudnya dia akan dissociate completely, ionize completely. So you have high concentration of OH minus. And then you will have high base dissociation constant. Banyak ya. Banyak awak punya, actually full. Awak punya apa ni, degree of dissociation alpha to 1 kan. So all your base dissociates completely. So the PKB will be low and the POH will be low lah. Okay. Ni negative log OH minus. Right. Okay. Next. For weak base. Terbalik lah. Low. Low. High. High. Okay. Boleh eh? Right. So this is to summarize, okay, what you should know, differences between strong acid and weak acid, okay, your strong and weak species. So your strong species will undergo complete dissociation while your weak species will undergo partial dissociation. So if you have a strong species, you will use the IF table where I is initial and your F is your final. Okay. Because you know macam dia undergo complete dissociation kan. So tak perlulah awak nak cari dia punya X tu. And it has no this apa Ke or Kb value. Alright. Okay. Whereas for your weak species, you will use the I table because your reactant and products, they are in equilibrium. Okay. So dia bukan complete dissociation, dia partial dissociation. They will exist in your equilibrium mixture. Okay. They will have a Ka and Kb value. Right. Okay. So when you are doing the calculations, macam tadi, I already showed you, right? I already showed you how for the weak species. So remember that when the okay, your initial pH value, it must have H plus or OH minus. Okay, if you don't have them, then you must create by adding water, usually for weak species. Okay, untuk yang ni. Right. Ni, on your left here, is the IF table for your strong acid and or strong base. So right here we have HCl, your strong acid kan. It will undergo complete dissociation. So maksudnya contoh kan, kalau awak punya initial concentration kat sini 0.10, then awak punya product is not formed yet. Okay. And then it will undergo complete dissociation, maksudnya dia akan diconsume sepenuhnya. Therefore, awak punya awak punya product akan produce with this concentration, okay? So, you get your concentration for H plus here. So, awak just masukkan je lah to find pH. If you want to find POH macam mana? Kalau POH, you will use this formula here, okay? Alright, so for weak species, okay, right here you have this weak base, ammonia. So it dissolves, it reacts with water, and then to form H plus and H. Apa benda ni? I think dia tersalah lah ni. Sorry guys, tersalah. Macam mana lah boleh tersalah? Okay, that is NH4 plus, okay? Ni salah ni. Salah. NH4 plus, okay, plus OH minus equals, right? Okay, so for this weak base, okay, it will undergo partial dissociation. Okay, you can see that it has a reversible arrow, equilibrium arrow. So, maksudnya ini macam dalam chapter 6 lah. You have to find the change in concentration and then you have to find the concentration at equilibrium. Alright. Kalau dia dah bagi tahu the percentage alpha, then awak boleh carilah dia punya X. Betul? Alright. So macam biasa yang ni betulkan lah. Ini bukan ini awak betulkan. Ni NH4 plus dengan OH minus. Okay. So over NH3. Alright, so when you already find the concentration of your hydroxide ion, you can find the POH. Okay, so if you want to find the pH, then awak just minus je lah 14 dengan awak punya POH tadi. Senang je kan? Kan? Right. Okay, so let's do this example here. Okay, simple je. So, in a sodium hydroxide solution, you have the concentration of your hydroxide ion, 2.9 times 10 to the power 4 molar. So, calculate the pH of the solution at 25 degrees Celsius. Okay, dia kata at 25 degrees Celsius kan, maksudnya awak punya pKW, awak punya pH campur dengan POH will be 14. Okay. Right. So, you already have the hydroxide ion punya concentration, so you can find POH. So, you will use negative log hydroxide ion. So, masukkan, awak dapat berapa? Masukkan value awak dapat 3.54. Okay. So, to find pH, macam mana? Betul tak je lah kan? So, 14 minus your POH. So, masukkan. Then you will get 10.46. Okay. That is one concept that you need to know. So, the rest, I think you can do it by yourself. So, saya tak naklah tunjuk banyak sangat example sebab nanti ambil masa yang lama. Alright. Okay. So, contoh tapi. Contoh saya just bagi pointers. Okay. Pointers. For example number 5, where dia tanya what is the pH of 0.25 molar of ammonia solution given the Kb. Okay, daripada Kb ni, first you need to write the ionic equation. Okay, dah tulis ionic equation, then you can write the Kb expression. Okay. Lepas tu, bila awak dah write the Kb expression, you know what to find lah kan? You know what concentrations you need to find at equilibrium. Tapi macam obviously awak tahulah kan? So from there, make sure awak note that awak punya Kb ni is 10 to the power of minus 5. So can you use any assumption? You can assume that the initial concentration kan, bila change tu, bila awak minus awak punya delta concentration, it is approximately the same as your initial concentration. Okay, so make sure awak cakap yang your X is very small. Berapa? Small macam berapa tu? Okay. So, and then awak boleh terus je use your initial concentration tu. So, daripada situ, awak bolehlah cari awak punya X. Okay. Awak punya X guna Kb ni. Awak guna ni kan untuk cari X daripada awak punya Kb expression. Okay. Ini, masukkan. Okay. Lepas tu, once you get that, you get the concentration of hydroxide ion. Okay. Once you get your concentration, you can find your POH. Once you get your POH, you can get your pH. Alright? Okay, senang je kan? So, chapter 5, 6, 7 ni memang banyak calculation. So, make sure to try. Okay? Tu dah ada jawapan dah pun. Right. Dah berapa lama ni? Okay. Dah 1 jam. Jadi saya nak stop lah. Yang belakang ni, I think you can do it. You want to classify each of the following. Betul kan? Dia 1 jam kan? Bukannya. Okay. Bukan 1. Bukan 1 minit kan? Okay. Bronsted acid, base dengan or both. So, Bronsted acid saya buat star. Bronsted base saya buat yang gini. Ni saya buat hashtag. Okay. What? Agak-agak macam mana? Okay. How are you going to answer this? How are you going to classify? So, first things first. You have to know that water, it can act as acid and base. So, it is both Bronsted acid and base. Okay. Second, you have your OH minus hydroxide ion. Okay. Hydroxide ion ni, all these other ones, what you can do is, awak boleh test dia. Awak boleh test with adding proton, atau awak boleh test with remove proton. Okay. So, kalau hydroxide ion, it is most likely to, kalau awak add proton, dia akan jadi apa? Dia akan jadi water. Okay. Boleh ke kalau awak remove proton dia? Dia dah lah negative compound. Okay, dia actually very basic. So, kalau dia boleh add water, maksudnya dia boleh accept proton. Okay, dia boleh form water, dia boleh accept proton, maksudnya dia adalah base. Okay, accept proton. Ingat tak? Bronsted cakap pasal apa? Proton transfer kan? Okay, H3O plus ni apa? Boleh, if you remove proton, you will get H2O. If you add proton, you will get H4O2 plus. Like, what the hell is that? Okay, so your H3O plus is an acid. It is most likely to donate its proton. Right, NH3 pula macam mana? So, kalau awak add proton, kalau dia accept proton, maksudnya dia akan jadi NH4 plus. So, okay. So, maksudnya dia adalah base. Ingat tak? Dia weak base kan? Ingat kan? Okay, NH4 plus pula, kalau awak tambah proton, kalau awak accept proton, jadi apa? NH52 plus. Okay, it is very unstable and tak pernah lah lagi saya jumpa. So, kalau awak remove proton, dia akan jadi apa? Akan jadi NH3. So, it is most likely that this is your Bronsted acid. Dia akan donate proton. Okay. NH2 minus. Saya nak tahu ni. If you remove one more, if you donate proton, if NH2 minus donate proton, what happens? Dia jadi NH2 minus. Faham tak? NH2 minus kat atas tu. Okay. So, not likely, okay? So, kalau awak accept proton, it will become NH3, okay? Which is much more stable. So, that means that NH2 minus is your base, okay? Oh, saya cakap nak guna ni kan? Lepas tu tiba saya tulis macam tu. Nasib lah. So, CO3 2 minus. Good. CO3 2 minus, if you accept proton, it will become HCO3 minus. Okay? So, tu ada Kalau awak remove, dia akan jadi CO4 3 minus. Oh. So, awak punya CO3 2 minus ni is a Bronsted base. Okay, dia accept proton. HBr, HCN. HBr is your acid. Okay, strong acid. HCN is your apa? Acid juga. Okay, dia ada H. Okay. So basically sebenarnya another trick is that if you have banyak H kan macam ni kan, maksudnya dia acid. Tapi tak boleh lah nak generalize. Okay. Tapi macam kalau bandingkan kan between these two, awak boleh tahulah yang NH4 plus ni acid sebab dia ada banyak H and dia ada positive charge. Alright. Macam tu. Okay. Okay. I think yang lain tu you can try it by yourself. Let's try doing this. Tiba lepas tu buat juga. So, ni sama macam ni, awak buat macam ni. Lepas tu awak tengok which species is donating proton, which is accepting protons. Then you can know who is acid, who is base, who is conjugate acid, who is conjugate base. Okay? Okay, yang lain ni kind of like a apa ni? Ada pointer sikit kan, so awak boleh tahulah. Okay, kita buat yang ni. Last. Okay. Table shows the base ionization. Tak nak. Bukan ini. Saya nak buat ini. Okay. This table shows your acid and the Ka value, acid dissociation constant. So dia kata arrange the acids in descending order of acid strength. So maksudnya descending daripada besar ke kecil kan. So maksudnya paling strongest, right, to weakest. Kan? Right. So let's see who is your strongest acid and who is your weakest acid. So what can you tell from Ka? Ka is your dissociation constant. So the smaller the Ka, that means that the smaller the dissociation constant. Right? I mean your degree of dissociation. That means the strength of your acid macam mana? Lagi tinggi ke? Lagi kuat ke? Lagi weak? Okay? Kalau dia dissociate partially kan, macam weak acid, dia akan weak lah. So, which acid is the strongest? The one with the biggest Ka. So, that means that HNO2 is your strongest acid. Okay. Second will be CH3COOH. Dan siapa yang paling weak ialah HCN. Macam tu Okay. Yang lain ni awak boleh lah buat sendiri Dia ada pointers sikit. Pointers as in, you know, this kind of jawapan sikit-sikit. Okay. Itu je for today. Alright, thank you guys. Yeah, so coming up is the part 2 of 7.1, okay? And then we will go into 7.2 and then 7.3. Alright, bye. Assalamualaikum.